This is the second video in the HOYS LCO project. In the first video, I showed you how to capture the images using the HOYS telescopes, and in this one, I'll show you how to process the data on the HOYS server. So your images should have been stacked and uploaded to the HOYS server for you, and the HOYS server link is on the HOYS website at hoys.space. Your username for the HOYS server is HOYS-LCO, and you'll get a password by email. And if you image the Cocoon Nebula, then your images should look something like that. When you log into the server, click on the Process Files menu item. So you'll have three lines, one for each image, for each filter, a red, green and blue. To process each image, you need to go through 4 stages, and there's a button for each one. When you can actually do a stage, the button should be darker blue. So if we look at the first 2 images, no processing has been done yet, so you can only work on the first stage. The third image shows that 3 stages have been completed, and you can only now do the 4th one. Make sure you only process your own files, the ones with your name on it, because there could be other ones there as well. And you can use the Get Help button at any stage to be more detailed information on what you should be doing at that stage. So let's process the middle row, the red filter image, and we'll start by clicking on Observation Target. So all we have to do here is to select the object that we imaged, in this case IC5146, the Cocoon Nebula, and that's HOYS target 119. And we also have to choose the telescope that we used. There should just be one option, the LCO 0.4 meter, and then click on the green button if everything looks correct. Now we can see that the second button has been enabled, the metadata, and we can move on to that stage. The software will try to extract this information automatically from the file. It's trying to get the observation date and time, and that's in modified Julian date format. It'll try and extract the filter used, in this case a red filter, and also the cumulative exposure time. We took 320 seconds exposures, so that should total 360 seconds. This is showing just underneath that, but that's okay. So we'll click on the green button as everything looks okay. Now we can see the third button has been enabled, and we can move on to the astrometric calibration phase. Again, this is mostly automatic. You told the software which object you'd imaged, so it'll extract all of the stars in the image and try and overlay them with a red dot. So if the red dots align with the stars in the image, then the astrometry has worked, and you can click on the green button. If for some reason the red dots don't align with the stars, you may have entered the wrong object earlier on in the process, and you might need to go back and fix that. But everything looks fine here, so we'll click the green button. And now we can move on to the 4th stage, the photometric calibration. This is slightly more complicated. The top graph shows you the raw uncalibrated data. So each black dot is a star, and its magnitude is plotted on the x-axis. On the graph underneath, the red dots show the calibrated magnitudes. You can find out more about the calibration process on the website, but basically it's making magnitudes consistent across all observations. To the right hand side of this vertical green line down here, some of the dots are still black. They haven't been calibrated, so we can't use that information yet. So we need to adjust the max use parameter, and the max and min use parameter boxes are just below these graphs. These values work on the x-axis of the top graph. So what we need to try and do is to move this green line to the right so we can use some of those black dots. So let's set the max use to 18.5 and click the blue button to retry the calibration. Now we can see that the green line has moved to the right. The dots that were black have now been calibrated and are red, and the only things to the right of that green line are some lines of black dots, which is probably some form of anomaly in the system. So everything looks correct here, so we can click on the green button. That's pretty much the graph that we should expect for every correct photometric calibration. And now that that image has been totally processed, that line has been moved from the file list. You need to complete all 4 stages for each of your files, and you can do it in any order as long as the blue button is enabled. Let's do the blue filter now, and if we look at the photometric calibration for that, on the top graph the left hand side is slightly different now, and that is probably caused by saturation of some of the brightest stars. And we can see on the bottom graph it also looks slightly different. So we need to try and remove these stars from the calculation. So in this case, if we set the minimum use to 10.2, that should remove those stars there. And we'll try 18.5 again for the right hand side to try and use some of these black dots to the right of the green line. Click on the blue button, and the top graph now shows something slightly different on the left hand side. That looks correct now. No obviously saturated stars, but on the right hand side the blue line seems to fall off very steeply, so we maybe want to try and remove those stars from the very end. So if we set the maximum use to 18.2, that should remove those stars there. And after pressing the blue button, the top graph looks correct and the bottom graph also looks correct. The only stars still to the right of the green line look to be vertical lines again, so an anomaly as before. So after this point we can press the green button to accept the data. So that's a very basic introduction to processing images. You can find more information at each stage using the help button or on the website. And there's also a detailed video there of going through a similar process. So that's it for this video, and we'll cover analysing the light curves and working with images more in another video.